All right, hello students. So we worked on finding the derivative function or the gradient function last time. Those two words are interchangeable in the IB curriculum, so just be aware when it says gradient, you can think of slope, you can think of derivative, you're just finding the rate of change. And so just all those words are equivalent here. And the gradient tells you what happens with the tangent line. So let's draw just an arbitrary curve. And let's say I care about the gradient at this point. And let's say that, in fact, I want to find the tangent line at that point. The derivative, the gradient, will tell me the slope, but I still need to actually write the whole equation of the line. And then there's another term that you'll see. So this is the tangent. There's another term you'll see which is called normal. And normal is another one of those words that shows up and has lots of synonyms. Normal means it's perpendicular to the tangent line. So it's perpendicular to the curve at that point. Um, it is related in physics to like the force as you're moving. If you want to balance as you're going around a corner, you kind of can go lean normal to the curve as you're going. If you're on a bike or if you're skiing or something, you're normal to the slope there. You can also think of it as perpendicular. You can think of it as a right angle. Later on this year, we'll start using the word orthogonal, which is just sort of the same idea as normal, but we typically use that when we're talking about vectors and planes, I should say. Okay, anyway, so let's do just an example. So I'll write down a function. Let's say we have some particularly nasty function like square root of x plus 2x cubed minus 17 pi. I don't know why we have this function, but the we want to find both the tangent and the normal, and we want to find it at the point where we have 0. Let's just say x equals 0. Okay. So at the point where x equals 0, we want to find the normal and the tangent. So let's go through our derivative function. So f prime. Remember, we're not using our shortcuts quite at this point. I'm going to do it from first principles. So the limit as h approaches 0, there's f of x plus h. These parentheses are just for visual. And then minus f of x. Those parentheses are actually important because of the distributing the negative, all divided by h. Okay, what I'm going to do is split this up into two different things. First, I'm going to get rid of the 17 pi because a minus 17 pi and a minus negative 17 pi are going to disappear. And then I'm going to split it up so I can handle the rationals and handle polynomials. So the rational side is the limit as h approaches 0, x plus h minus root x over h. I'm going to leave a little space there. And then the polynomial side, and you're allowed to do this because you can always distribute a limit across addition and as long as both of the original limits exist. And so then here I have 2 times x plus h cubed minus 2x cubed over h. So the reason I left some space over here on the radical one is because I'm going to multiply by the conjugate, because this is going to get rid of my square roots on the numerator. Okay, let's see if I can squeeze this in over here. So the numerator becomes, for the radicals, x plus h minus x, and the denominator becomes h times root x plus h plus root x. On the polynomials, I have 2 times x cubed plus I have 3x squared h. So I'm going to call that 6x squared h. I have 3x h squared, so 6x h squared. And I have 2h cubed minus 2x cubed all over h. And somehow I'm going to squeeze the limit in there. Okay, lots of nice things happen now. X here minus x here. 2x cubed minus 2x cubed. Everything else has an h in common. So now we're down to limit as h approaches 0 of 1 over root x plus h plus root x plus 6x squared h. Oops, sorry, the h is going to disappear. So I just have 6x squared. Let me erase that actually, because I'm canceling the h that was on the denominator. So 6x squared plus 6xh plus 2h squared. And as that h approaches 0, now I don't have a division by 0 problem. I have 1 over 2 root x, because this is a root x plus another root x, plus 6x squared. And so that's my derivative function, f prime of x. So then if I care about where x equals 0, I run into a little bit of a problem, because this right here is not defined when x equals 0, which I should have known, because the square root function is not defined to the left of 0. So that's a little mistake on my part. That's okay. We'll just change the example. Instead of looking at x equals 0, let's just look at x equals 1. Square root's defined on either side of 1, so it's differentiable there. Okay, so what do we need? We'll get f of 1. So I'll go up to the top. F of 1 is going to be the square root of 1 plus 2 times 1 cubed minus 17 pi. Okay, I got to move my little face around again. So we end up with 3 minus 17 pi. That's like the y value. And if I do f prime of 1, I get 1 over 2 root 1 plus 6 times 1 squared, which becomes 6.5. You can use decimal or you can use a fraction. Okay, so to find my tangent line then, I'm going to create a little bit of space to write here. So I'm just going to erase some of this line right here. So my tangent line, the idea, you learned this back in algebra class, allegedly, but the idea is that you can always write a line as y minus y1, sorry about the lag, equals m times x minus x1. This is point slope form. And so I'm going to write my tangent line as y minus the y1, so minus 3 plus 17 pi, right, equals m 6.5 times x minus 1. Looks like the 6 didn't come through. So that's the tangent line. You can solve for y if it makes you happy. You really don't have to. And then the normal line is very similar, because the normal line touches the exact same point, but the normal line has a perpendicular slope. And you learned back in algebra class that that's the opposite reciprocal. So it's -1 divided by the slope. So we go -1 divided by 6.5. 6.5. Try again, get the 6 in there, and then x minus 1. And that's how you find a tangent and a normal line. So sorry about the lag towards the end of that there. Please comment, ask questions if there's anything I can do to help, and thank you for watching.